All right, this is from last year, a review of the unit circle. And like I said, you guys are just going to love this and be happy about it and want to learn more and more and more, right?
Yeah, most definitely.
All right, so we're going to start off first of all today just kind of reviewing. This should be review, and I know a lot of it probably isn't going to seem like review, so we will hopefully figure out any holes that you guys have. So you all should have in front of you the unit circle. I am just going to say right now that you are allowed to use your unit circle on the test. So it would be to your advantage to make sure that you're writing legibly, that you are not missing details and so on. Make sure that you are, doing a good job of filling in this circle. So what we're going to do today, we're not even going to worry about radian measures yet. We're just going to talk about degrees today. All right, so these little degrees symbols all the way around the circle, some of you could probably go through and just fill them in right now, but others of you might need a quick review, so that's where we need to talk. Remember when you are looking at a circle, for whatever reason, we always start the unit circle right over here on the right-hand side. We call that 0 degrees. And if you rotate around the circle in a counterclockwise direction, in other words, if you are headed this way around the circle, you are moving in a positive direction. For whatever reason, when you rotate counterclockwise, that is considered a positive direction. If you move down first, in other words, in a clockwise direction, that means that you are moving in a negative direction. All right, so if I start here at 0 degrees and I rotate all the way to the tippy top up here, so I'm all the way up here, how many degrees have I rotated?
35.
90 degrees. Okay, now listen, it's 90 degrees because if you look here, right in the center, you see how if you are right here and you rotate all the way up, did you see the right angle that's formed there? Looking here, we've rotated 90 degrees, okay? Now, if I keep going in a counterclockwise direction and I end up over here on the far left, that is another 90 degrees, which would put me at 180 degrees. And then if I rotate another 90 degrees, you are going to be at 270 degrees. I'm going to shrink this just a little bit. I'm running out of room. All right, so we had 0 degrees here. We had 90 degrees over here. Over here we were at 180 degrees, and then at the bottom we are at 270 degrees. And then if you rotate back to where you started, that puts you at 360 degrees. Now they have these places for you to fill in between the 0 and the 90 degrees. And notice that they're not divided equally. But if this middle one, this one right here, was not there, we would have 3 equal pieces that we would have to divide that 90 degrees into. So if we start here at 0 degrees and we rotate up to this blank right here, how many degrees have we rotated? 30 degrees, all right? So this is 30 degrees. Skip the one that I have kind of marked here in blue just for a second. And go to the next one up here, that would be 60 degrees. And then if we go back, what would be halfway between 30 and 60 degrees?
45.
It would be 45 degrees. All right. Now if we're up here at 90 and we continue to rotate counterclockwise, we're going to rotate another 30 degrees, which would put me at 120 degrees. Rotate another 30 degrees, that would put me at 150 degrees, and then halfway between 120 and 150 would put me at 135 degrees. Is this coming back to you guys? All right, good. So we have 180 degrees over here on the far left. Now if I keep going, add another 100, or add another 30 degrees onto it, it puts you at 210. Rotate another 30 degrees, that puts you at 240 degrees. Halfway between 210 and 240 would put you at 225 degrees. The bottom we're at 270 degrees. Do the same thing for the last quadrant. If I rotate another 30 degrees, that puts me at 300 degrees. I'm going to skip that one in the middle again. I'm going to be at 330 degrees, and then of course halfway between 300 and 330 degrees is 315 degrees. And I want you guys to remember too that this unit circle is just a circle that sits right in the middle of the x and the y axis. So this line right here, right down the middle, that's just the y-axis. And then the one that goes horizontally, obviously, is just the x-axis. So what we really have here is what we call 4 quadrants. This one right up here is what we call quadrant 1. What do we call this one down here? Quadrant 4. Yeah, because remember, and the reason it is, you'd think it'd be quadrant 2, but remember when you rotate around a circle, you always rotate in a counterclockwise direction. So if we start here in quadrant 1 and we rotate counterclockwise, we end up over here in quadrant 2. Down here we are in quadrant 3, and then of course over here you are in quadrant 4. It is probably important for you guys to know which quadrant you're in at what time, because at sometimes you'll have problems where we say in quadrant 3 this is happening. You're going to need to know what quadrant it is that you're talking about. All right. Now what we need to do is we need to start filling in our x's and our y's. So in other words, we need to start filling in these points. So this is where we kind of need to review a little bit from last year. If you are looking at, well, let's back up here. Let's go to 0 degrees. If we really are, in fact, talking about a 1-unit circle, this circle right here that sits right in the center of the x and the y axis, this point over here, does anybody remember what that point is called? It is the point 1, 0. And that is because it is from the center of this thing, it is over exactly 1 unit. If this thing is called the 1-unit circle, had it been the 2-unit circle, this would not be the point 1, 0, it would be the point 2, 0 instead. Does that make sense? If it was a 3-unit circle, it would be 3, 0, and so on. So if this is the point 1, 0, what is the value of the point up on the top? It would be, the x value would be 0, the y value would be 1. So right here we have 1, 0. Up here on the top we have the point 0, 1. On the left we have negative 1, 0. What about over here on the bottom? In other words, this point right here, what is that point? Has an x value of 0, it has a y value of negative 1. So this is the point 0, negative 1. 0, negative 1. So if I gave you a blank copy of a unit circle right now, would you be able to do what I just did? Would you be able to label the degrees that are marked on there at least, and then give me those 4 key points, 1, 0, 0, 1, negative 1, 0, and 0, negative 1? I don't think those are too bad. So when we start talking about 30, 45, 60, and so on, they get a little bit more complicated. So what I need to do now is kind of take you back to, I don't know, probably geometry is when you guys learned this. I'm going to switch colors here. Change it to green for just a second. Remember if you had a triangle that looked like this, and you knew that that angle was 30 degrees, I should be more specific and say that this is a right triangle. And that angle right there was 30 degrees, and you knew that the hypotenuse of your triangle, if you knew that it was 1, how would you go about figuring out the value of the bottom of the triangle? How long the bottom of the triangle was? Do you recall? SOHCAHTOA, yes. You had to use SOHCAHTOA. I will write that acronym down here. S And we are gonna spend more time working with SOHCAHTOA, but for right now, I'm just gonna write the acronym up here. If you are trying to figure out the bottom of this triangle, I'm gonna call it X. That X is adjacent to 30 degrees, and this right here is the hypotenuse. So we have adjacent and hypotenuse. We're trying to find the adjacent side. We already have the hypotenuse. Which of the three trig ratios is that?
Cosine.
Cosine. So that means we would do the cosine of 30 degrees is equal to the adjacent side. Which side is adjacent?
X.
The x. The x divided by the hypotenuse. What's the hypotenuse? It is 1. To solve for x, which is being divided by 1, we just have to multiply both sides by 1. Is it necessary for me to even multiply by 1? No, but that is the math behind it. We have 1 times the cosine of 30. So you go to your calculator, you type in the 1 times the cosine of 30, and you should get this awful answer. And I think the awful answer is like 0.866, blah, 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 blah.
Oh wait, are we supposed to go to
You have to make sure, yes, you got to make sure that your calculators are set in degree mode. If they're in radian mode, you're going to get something crazy. So you do the cosine of 30, making sure that your calculator's in degree mode. The cosine of 30 is 0.866. Now it just so happens that 0.866, the cosine of 30 degrees is equal to 0.866. It just so happens that 0.866 is the same thing as the square root of 3 over 2. So that means that the x value of that point at 30 degrees, the x value is the square root of 3 divided by 2. The square root of 3 divided by 2. Let's put it on my desk. And the reason it is because right here in this circle, I have a right triangle. I have a right triangle that has a 90-degree angle down here. And right here we have a 30-degree angle. I know it's a 30-degree angle because remember I have rotated up here 30 degrees. This 30 degrees on the outside of the circle, a 30-degree arc, is the same as that 30-degree interior angle. So this triangle that I have just created here in blue, and I do know this is getting very, very messy, but that triangle that I've just created matches this green triangle over here on the right. So how did I know that 0.866 is equivalent to the square root of 3 over 2? Well, there are tricks to that too, and we could talk about those too, but I don't want to talk about them today. And I've done this before too. So I know that 0.866 is the same thing as the square root of 3 over 2. But this thing also has a y value. It also has a y value. What do you think I am going to use to find the y value? Here I did the cosine of 30 degrees to find the x value. How am I going to find the y value? Mm-mm. Is it what? Well, we do have the x value now, so we certainly could use a squared plus b squared equals c squared, but I'm going to call this side over here y now. Ignore the fact that we know what x is. This is y now. So if this is a 30-degree angle, what is y in comparison to that 30-degree angle? Yeah, it's opposite. This is the hypotenuse. Which of these three trig ratios, SOHCAHTOA, uses opposite and hypotenuse? Sine. The sine does. So now what we would do is say, okay, well, we're still talking about a 30-degree angle, so we would do the sine of 30 degrees is equal to opposite y over the hypotenuse, which is 1. How do I solve for y? You multiply by 1. So all all you have to do is type in 1 times the sine of 30. What is 1 times the sine of 30?
Hold on.
It's 0.5, yeah. Now, for those of you thinking, do we really have to do this every single time?
Well, yeah.
Absolutely not. No, I'm showing you the math behind where these numbers are coming from. I think you get 0.5. So the y value at that point is 0.5. So let me just talk to you about what you did. At 30 degrees, to find the x value, all you did was take the cosine of 30 degrees. To find the y value, all you had to do was take the sine of 30 degrees. Okay? So keep that information up here. Do the same thing for 45 degrees. Do the cosine of 45 degrees. Do it, do it, do it, do it. What is the cosine of 45 degrees?
0.707.
It's like 0.707, blah, 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 blah. It's a horrible, irrational number.
Blah, blah, blah.
Blah, 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 blah. Does anybody remember from last year what is equivalent to 0.707, blah, 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 blah? Square root of 2 over 2. Sure. Oh, yeah. I said, yeah. Okay, Mrs. Corrigan, I remember that.
Nope.
Square root of 2 over 2. How do you find the y value there? How do you find the y value? You do the sine of 45 degrees. And yes, it is going to be the same. You do the sine of 45 degrees. What is the sine of 45 degrees? Isn't it 0.707 again?
I'm thinking it's 0.707.
I'm talking to a wall right now. 0.707, yeah? What is 0.707? Square root of 2 over 2.
Nice job, Cody.
So listen, guys.
Woo.
If you are trying to find the x value at a point, all you have to do is take the
Cosine.
cosine. If you are trying to find the y value, all you have to do is take the
Sine.
sine.
Make sure
Okay, so let's do it. 60 degrees, quickly. What is the cosine of 60 degrees? 1/2. Find the y value.
0.707.
You do the sine of 60 degrees.
You do the 0.707.
No, you get 0.866, blah, 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 blah.
Yep.
All right.
3 over 2.
Oh.
So you get the square root of 3 over 2. So it's 1/2 square root of 3 over 2. Notice 30 and 60 degrees. What do you notice about them?
Opposite. Their thingies
They're opposite.
Yes, all you have to do is just switch them. The x and the y switched. All right? What about 120 degrees? Do the cosine of 120 degrees.
Negative 0.5.
Negative 0.5. Oh my gosh, it's negative. Is that okay to have a negative?
No.
Absolutely, yes, it is. Over here in quadrant 2, the x values are negative. All of the x's in quadrant 2 should be negative. Okay? So you're going to get a negative 1/2.
Oh.
Now do the sine of 120 degrees.
3 over
Hey guys, is it going to be positive or negative?
Negative, probably.
It's going to be positive, and it's going to be positive because
That's what I meant.
in quadrant 2, a negative was right.
Yeah.
Okay. In quadrant 2,
Cancels out.
the x values are negative, but the y values are
Positive.
positive. So you should get a positive square root of 3 over 2.
Yep.
This one, cosine of 135 degrees. It's going to be negative because it's an x value and it's in quadrant 2. So it is, I believe, negative square root of 2 over 2. What about the sine of 135
This
degrees?
is the opposite of 80 degrees.
Square root of 2 over 2. It's positive. It's a y value, and in quadrant 2, the y values are positive. Next one, cosine 150.
It's going to be the opposite.
Negative square root of 3 over 2.
Yes, it's going to be the opposite of 120 degrees. So it's going to be negative square root of 3 over 2,
I thought
comma,
that's 80 degrees.
1/2. Do the same thing all the way around the circle. Cosine, sine, cosine, sine, cosine, sine, cosine, sine. Okay?
Is that fun
In
to say?
quadrant 3, x's are negative, so are the y values. So everything down here is going to be negative. But in quadrant 4, we got an
That'd be
email
this
this
one.
morning saying that we had Rocket 30 today, right?
Yeah. Oh, maybe. Go. Text her.
Alright, so I